All right, my friends, so we're going to take a quick look at what's called a slant asymptote. So we're going to look at this function here and try to find how it behaves as it approaches x equals, say, plus infinity and minus infinity, and then we're going to graph the function. So in plain English, the slant asymptote is just a line that the function approaches, again, as the input to the function goes towards, say, plus or minus infinity. One way to tell the slant asymptote is coming is just to look at the degree of the, say, the numerator and the denominator. And you notice the numerator, we have a x squared type function being multiplied by x to the first type function. So the numerator is going to go like x cubed. And the denominator, you have x to the first function times an x to the first function. So the denominator is going to go like x squared. So we know that this thing is going to approach an x to the first type function when x gets real big in both the positive or negative directions. Now the thing you have to watch out for though is that that line that it will approach could have an intercept. And so we do have to suck it up and calculate the quotient of this thing in order to see what the form of that line is going to be. So let's set this up. What we're going to do is expand both the numerator and the denominator and then evaluate the quotient to see the functional form of this line that this thing is going to approach. So let's go for it. So all we're going to do is expand this out. So x minus 2 squared just becomes x squared minus 4x and then plus 4. And then we have to multiply that by x plus 4. And then the denominator, well, we have this 2 sitting here. And then we have to combine these two terms. So this is going to be x squared, and then we've got a minus 1x and a plus 2x. So that's just going to be a plus x. And then we have minus 2. So if we go one more move with the numerator and denominator, we'll be ready to do some division with these polynomials. And so let's go for it. So the first term here, we have to distribute this x to everybody. And so what we're going to get in the, again, just doing that, we'll get x cubed minus 4x squared plus 4x. That's handling this guy. Now we got to distribute the 4. So we're going to get a plus 4x squared minus 16x and plus 16. So that's all the numerator. We'll simplify it in a moment. In the denominator, we really just need to distribute that 2. So you got 2x squared plus 2x minus 4. And then let's simplify this just before we divide. So the minus 4x squareds will go away. I take that back. So what we're going to do now is just evaluate this quotient. So we're going to divide this polynomial into the one above it. So let's do that. So we'll do it long division style. So what we're trying to do here then is say 2x squared plus 2x minus 4. We're dividing that guy into this thing, into x cubed. There's no x squared term. There is a minus 12x term. And then plus 16. So let's go for it. So how many times does this go into here? Well, you can see that if you multiply this guy by 1/2 x, 1/2 x times this will give you x cubed. 1/2 x times 2x will give you 1x squared. So this is going to be plus x squared. And then 1/2 x times minus 4 will give you a minus 2x. Right? So we've got the first term here. Now we've got to subtract this off and get the next part. So this will go to 0. This will go to minus x squared. And then we have minus a minus 2x, so that's plus 2x. So minus 12x plus 2x. So that's going to be what, minus 10x? And then plus 16. And then what we can, so one more little move. This function, how many times does it go into into here. What we need to do, you can tell, is multiply this guy by minus 1/2. So you'd have minus 1/2 times this thing will give you a minus x squared. And this would give you a minus 1/2 times 2x. That's going to be minus x. And then minus 1/2 times minus 4, that's going to be plus 2. And so now we're going to see what our little remainder is going to be. So we need to subtract all this stuff. And so that term goes away, as it should. This will be minus 10x plus x. So this is going to be minus 9x. And this is going to be 16 minus 2. So that's going to be 14. So finally, in all its glory, this quotient is 1/2 x minus 1/2. And then we have minus, it has this remainder of 9x plus 14 over the function, over 2x squared plus 2x minus 4. Okay, so here is our quotient. Right, that's what this function is equal to. Now what we want to do is we're looking for the behavior as x gets, like, say, really, really big. Well, what you notice is as x gets really big, this term will dominate over that one because you have a squared term here and only x are the first there. So as x approaches infinity, this term is going to get vanishingly small. So this is gone as x goes to infinity, let's say, or minus infinity for that matter. And so what you see is as x gets big, I'm going to say or minus infinity. And so what that means is when the value of x gets huge is that the function is just going to approach this function, which is just 1/2 x minus 1/2. So 1/2 x minus 1/2, that is your slant asymptote. Okay, and so now what's cool about that is we're going to actually be able to plot this thing. So we have to remember, okay, so 1/2 x minus 1/2 is our slant asymptote. So let's go for it now. So here's our function, this crazy function, and we're going to graph it. So we already learned that the slant asymptote is 1/2 x minus 1/2. And so what we need is a line with a slope of 1/2 that goes through here. So let's just sketch that in. So a slope of 1/2 means when you go over 2 units, you only go up 1. So we can kind of, plot that guy in. Go. And so I'm just going to dot this in. So this is going to be the function that our function will approach as the value of x approaches plus and minus infinity, right? So now once we have that, then we can fall back on our other techniques for plotting functions like this, like finding asymptotes and zeros. And so let's go for it. So one thing we can do to start plotting this thing is let's get the zeros. Where does this function go to 0? Well, so f equals 0. Where is that? Well, you can see that's when x equals 2, or when x equals minus 4. So let's put those in there. So we know when x gets to be 2, that's going to be a 0 of the function. And when x gets to minus 4, that's going to be a 0 of the function. So we've got that part. Another thing that you can do is look for the y-intercept, which of course is so that's one set of points that we have for plotting this beast. The other thing we can do is look for the y-intercept. That's obviously when x equals 0. So what we need to do is just set x equal to 0 in there. And so what that would do is give us minus 2 quantity squared times 4 all over 2 times, what is that, minus 1 and 2. And so that's going to be equal to, what do we got? This is minus 2 times minus 2 will give you plus 4, and then 4 times 4 will give you 16. And in the denominator here, we've got negative 4. So what that means is your y-intercept then apparently is negative 4. And so let's go down there and do that. 1, 2, 3, 4. Oh, it's down here. Okay, so there's our y-intercept. So there's that little bit of info. Right, now the next thing we're going to do is find the asymptotes. So these would be places where the function blows up. So in other words, the denominator would go, a term in the denominator goes to 0. Then the function will explode. It'll go up, or it'll go way down to minus infinity. And so you can kind of tell that that happens. The vertical asymptotes are going to be when x equals 1, because that would make a term in the denominator go to 0. So we can put that guy in there. That's one of our vertical asymptotes. So that's x equals 1. And then our other one is when x equals negative 2. So let's put that one in there too. So that's x equals minus 2. Going on up. So we're almost ready to plot this thing. What we then can do now that we have these asymptotes, so the function's either at plus or minus infinity as it approaches these vertical asymptotes. So we just need to figure out where it is. And a nice way to do that is just take a look at the sign that the function has when you're on kind of either side of the asymptote. So for instance, let's just go left or right. So for here, we kind of need to know when we're just a little left of negative 2, what the function's doing. So for example, say we look at x equals like negative 2.1, just to see what's happening. Now all we want to know is the sign. Is it real big positive direction or real big negative direction? So let's just look at the sign when x equals negative 2.1. Well, so let's go up here. This term is going to be positive no matter what, because you're squaring it. So we get a positive. What are we at? Negative 2.1. That's going to be positive. So we get a positive times a positive over. At negative 2.1, this term is going to be negative. And at negative 2.1, this term is also going to be negative. So we get positive over positive, because negative times negative gives you a positive. So that's going to conspire to be positive. So what that means is when you're over here, we must be coming down from way up here. Okay, so already we kind of have the shape of our function. On this side anyway, it's got to come down, go through our intercept, because of course it does. We found that goes through there. And then it's got to approach this line. So there's the behavior in that little zone for the function, right? So now we got to kind of work on this side. So let's just go left or right. So next we need to know what's going on at like negative 1.9-ish, right? So we need to kind of see what's happening there. So let's try that. So if we go to negative 1.9 and just repeat the process. Right, so here at negative 1.9, that term has to be positive because it's squared. That term is going to be positive at negative 1.9. That's going to be negative, and that's going to be positive. So we have positive divided by a negative, so that's going to conspire to make negative. So what that means is the function here is going to be way down here somewhere. Boy, I got to go way low on the graph here. So it's going to be down here. So we know it's going to come from way down below and come up to this intercept. Right? So now we need to know, so we're getting there, we got to do two more. We got to check this side and that side. So let's do that. So if we look at x equals, say, 0.9. Let's look there. X equals 0.9. Let's check signs. That's got to be positive. That's got to be, well, it is positive. 0.9 minus 1, that's actually a negative number. 0.9 plus 2, that's a positive number. So this is a positive number over a negative number, so that's going to be negative. So that means that this is going to have to go at this asymptote, when you're on this left side of it, it needs to approach negative infinity. So that part of the function is going to live here. Right? Very last part, we just need to know what's going on here, whether this comes from below and approaches the line or maybe comes from above. Let's check this out. So we need to look at, for instance, x equals 1.1. let's take a look at what happens there, just to get the signs. So when you're at 1.1, this term is a positive because it's squared. That term is positive, 1.1 plus 4. 1.1 minus 1, that is positive, and this is also positive. So everything's positive, so that means it's got to come from up here. Now this is where this gets sneaky. We know it needs to approach this line, right? But it also needs to touch the axis here. And so what that means is it's got to go down to our point, but then it's got to come back up and approach this asymptote. Okay, so in all its glory, here is that crazy function. Over to the left of this asymptote looks like this. Here, it's this opening downward function that heads towards minus infinity. Here you come from plus infinity, touch the axis here, go by the axis here, and then it turns around and heads up like this, following this slant asymptote. So again, big deal here. Way to recognize that a slant asymptote is coming is just look if the degree of the polynomial on top, for instance, is 1 higher than the degree of the polynomial below, then that means your long range behavior is going to go like x to the first. And then the idea is you do have to do a little bit of grinding to see what the intercept is of that line. So we knew it was going to be a linear asymptote, but we did have to grind a bit to find that intercept. Well, you can see from the plot here that we did a pretty decent job of matching the actual graph of this thing with our sketch on the whiteboard. Managed to reproduce this crossing at x equals -4 and the approach to the asymptote. And also thing to mention here is notice that in coming down from infinity at this vertical asymptote at x equals 1, we did cross the slant asymptote and then turn around and approach it from below. So you see that feature of the graph reproduced in this actual plot as well.